Hello, my dear patrons. Welcome to the Malware Development Point 8, where we're going to discuss pointers and why they're useful and why you need them. You see, in language like C and C++, the advantage of the language is that we can use pointers as a variable types, and no other language can use that. Pointers, essentially, are types of variables that can directly engage with the memory. Yes, with the pointers, that's the power of the C and C++ language that using these things called pointers, you can directly read memory, write memory, allocate memory, engage with different window structure, obtain more detailed information, and potentially modify this information. Essentially, we can engage with the memory itself. Now that's super important thing that I need to explain. And in programming, we have two types of passing data. You know, in the previous videos where I showcase how the functions work, and we're gonna go a little bit about that in now, I explained that if you call a function and you call it in the main is gonna execute first until it has function. When the function occurs, it's gonna go back to the function and execute what's inside. However, functions in order to operate, they often require what's so-called parameters or arguments. This is what you essentially specify the function to accept. So when you call the function, you need to pass specific data to the function so it can work with. The best functions are the one that does only one specific thing, solves only one specific problem, and only requires some specific data. So essentially, if there's a function of summing two numbers, it can require two numbers. If I pass three or even one, it's not going to work. So essentially here, I have created two functions which has just one simple idea, and that's to showcase how the pointer works and how to do passing by value and passing by reference. This passing thing, when we have to pass our data to specific functions, can be as mentioned either as a value or as a reference. And that thing is huge and it's super important for you to understand what's actually going on under the hood. So you have the following piece of code. Let's walk it through and explain every single line just to showcase what it does and how does it work. First of all, we have our include libraries. We're gonna always have these because without them, essentially, we will not have things like printf, getch, and so on. So I include stdio.h, which is the standard library for operating with the standard output input things, I can say. Then we have the first function, which is called modify value. We have another function, which is called modify reference. And then we have the main. Now, this function may seem a little bit similar, but trust me, they are not. Essentially, both of these functions are of type void, which mean that nothing will ever get returned. Then we have the function name, and then we have exactly the same parameter, which is an integer number. This text do not mean that you have to provide a variable name text, but that's something that the function accepts as an argument. In that case, in the first one, we modify the value of the x to be 20. In the next example, however, we provide something a little different. Instead of just int x, we provide a pointer to a variable. Now the pointer is a variable type that can inherit different variable types. For instance, we can have pointer to be integer, pointer to double value, pointer to memory address, pointer to void, to nothing, pointer to character, and so on. Essentially, you have the same data types that we have discussed before, and you can have pointers to every single one of them. Like in that case, we have pointer for an integer value. In that case, we don't pass the variable itself, but we pass its address in memory. And this is done a little later in the line 16. Now, when that thing happens, we can modify the value in the memory of this variable be 20. And when it returns, the value is going to be 20 in the main. So in order to showcase how that thing works, I'm going to set up a debugger right here. And we're going to walk through that code one line at a time, explaining it in real time. So in that case, I'm going to switch to debug and then local Windows debugger. That's going to run the program and it's going to start execute one line at a time because I've set up the breakpoint there. Now, in that case, our program just started. We have defined the int value, and if I press step into, then we can see that the value is indeed 10 because the line 12 was executed first. Then in that case, the modify value function is called, which means that we are doing pass by value, because in that case, we are not passing the memory address of the variable, we are not passing any pointers that can point to specific memory addresses, we are passing just the variable itself, which means that by default, we pass its value. So for example, when you see a function call like that, and you don't pass a pointers or memory address or anything else, we pass by value. So in that case, we pass the value 10, and that's it. We don't specify the address of the whole address of the variable, but we specify the value, which in that case is 10. So this thing here, when you pass a variable, we do pass by value. So I'm going to step into to see what happens inside this function. And in that case, we can see that the x is indeed 10, which is obviously an intended behavior. Then see what happens. What that function does, it modifies the value of x to be 12. However, when we pass by value, when we don't pass addresses or pointers and so on, each thing that happens here is doing a local copy of the variable. So for instance, here, the function in that case accepted the value of 10, but this value of 10 is applied only for the function body. So in that case, here, the, the value is modified. However, it's modified only for the scope of that function inside because we pass by value. We just pass a value. This value can be changed inside the function, but the address itself is the same and the value inside is the same. So in that case, the value is changed, but as mentioned, locally for the function. We click next, 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 and here we print the value. So if I go step into again, we can see that the output of that printf statement is indeed 10. Why it's 10? Because as mentioned before, we passed the value to the function, which value was modified locally for the function, but the original value was not touched whatsoever because we did passing by value. In the next line, we just print it out, and that's why we get the 10. And then we have the getCH. In that case, the getCH is just a function that holds the user input, and now it waits for the user, in that case me, to pretty much press anything so it can continue. This is a nice mechanism that can allow you to stop the engagement of your code, just so you can pretty much pinpoint what's going on if you're not using the debugger. So in that case, I can click step into, and when that happens, I need to provide some kind of user input. In that case, I'm gonna just press enter. Now, when that happens, we are immediately redirected to the next line, which in that case is line 16. And here we call the function modify reference. Now see the difference here. In that case, we pass a reference, we pass an address to the real variable itself. And that's why you see this ampersand here. In C programming language and C++, of course, if you want to pass the address to specific variable, to somewhere, to some function, you have to use the ampersand before it. Because if we don't, we pass its value, which is going to do the same thing. So in that case, the first modification is that the function now accepts a pointer, and a pointer is once again a variable that points to a specific address. And on the function call, we pass, the address of the variable itself. So by just doing that, we pass the address of the variable. And then when this thing is changed, then it's going to be changed globally because we changed it in memory itself. I know it can sound confusing, but bear with me now. So I can click step into again. This is going to trigger the function execution. In that case, we modify the data of the pointer to be 20, not just the variable like we did before. Then we do step into again. We exit the function. We do printf. And after the printf, the output is 12. So this is a nice example that showcased what is the difference between passing a value and passing a reference. So Once again, passing the value means that the function is going to create a local copy of your variable and it's not going to be applicable outside of it. Where if we pass something as a reference, if that something is changed, it's going to be changed in our code completely. And to use that, we have pointers because using that, we can directly pass the address of our variable. And then when the value is changed, the address is the same and the value inside is modified. So that's why you get such thing. While passing the things as value and as reference is super important, there is also one more example that I want you guys to see. And this example is about memory allocations. So in this example, I can give you one more, I can say use case for pointers, and this is the memory allocation. As mentioned before, pointers are the only way for us to engage with the memory. Usually, languages which are higher in level, like C Sharp, Java, Python, and so on, they have these things called garbage collectors. So essentially, what that means, it's a system that runs in the background inside the environment of the language itself, which cares about that automatically. It allocates data as you need. When you create a variable or an array, it's gonna allocate the needed data. It's gonna increase the number of the data if you need so. And if you don't use the object, it's gonna determine when and how to pretty much kill it, free the memory, and then reuse it back again. But however, in C and C++, we don't have such things as a garbage collector as we are the garbage collectors. We as a programmers can decide how much memory to allocate, in what data structure this memory to be allocated, and essentially when to free it. And yes, it has more responsibility because if you allocate a lot of memory and forget to clean it up, bad things might happen. So here I have a simple example that demonstrates how the memory is allocated. And to prove it to you, we're going to use the debugger to showcase and to prove it where the memory actually is into the program itself. So essentially, let me go through this code one line again at a time so we can discuss it and better understand it. Here we again include all the needed libraries. In that case, stdio.h and stdlib.h. Then we define a pointer in pointer to an array. In that case, we are going to create an array with integers. And as mentioned before in my variables videos, array is just a combination of variables. So imagine I have a int value. So in that case, if I have int val1 is equal to 1, and I have int val2 is equal to 2, I can also have an array of values. So int array with two elements, and this can be one and two and so on. Yeah. So in that case, I can create an array with specific variables, and this can be an array of characters, which is actually a string, array of double numbers, array of anything. In that case, we define an int pointer to something which we call array, and that's when we know we're going to create an array because the name says so. So in that case, just on the line 6, it's not still an array, it's just a pointer to memory which can contain an int value. That's all about it. Then we define a new variable, which is going to be the size of our array. And then we're going to ask the user to input how big an array he wants. In that case, we're not using getSH because it's only for characters, but here we're using scanf. And scanf is a nice utility to pretty much engage with the user, ask him for data, but it can be used for different kind of buffer flows, so definitely be careful with that. However, if you somehow face the use scanf, you might also face the issue of compiling because scanf is not considered a safe function. If that's the case, you can actually bypass that if you go to your project settings, then properties, if you go to C++ general, and then remove the SDO checks. So in that case, do no. Okay, then when that thing happens, you can use scanf and you can use the same values for printing out stuff into actually inputting stuff. So if I print a number, it's going to be using the %d, and these values are all in online. I don't think it's worth paying that much attention to them. But essentially, if you want to print out a specific number, it's %d. If you want to input a specific number, it's again %d. Then the important thing is that we have to again pass the address of the variable because we don't want to pass this as a reference. We want to we don't want to pass this value, but as a reference. So we want to modify the value on that specific address, which is going to make him globally available. Then when that happens, we actually use one of the functions of the C programming language, which allows us to create memory, to allocate memory. In that case, the R, which is an in pointer, is equal to malloc, which is a specific function that allows a memory allocation, and we allocate the size of the array, point size of int. Size of is a function that returns the size of specific object, can be an array, can be a specific variable type, and in that case, we return the size of the integer itself. So when that thing happens, we also cast that to int pointer to make sure that we have memory allocated that can contain the exact specific data type that we need. So when that thing happens, then we can do an if statement here. So that's one practical example of where if statements are actually super useful. And this if statement is actually check if the allocated memory is there and if everything was all right. So in that case, if the R is no, that most likely means that there was some kind of an error while the allocation phase, and then we just print out that there was some kind of an error, and then we return one just to verify the user that something happened. So using a lot of if statements and checks, you can actually see what happens with your program and when exactly where does it crashes. So after that, we have a for cycle, and there it is one use case for the for cycle, as mentioned in my previous video. In this for cycle, the initial condition is that I equals 0. Then, while I is less than the size we specify, we increment I one at a time. Then, in that case, we instantiate and fill out the arrays with values. So in that case, R of I equals I plus 1. Okay, yeah. And then we just print FDR. This is just for showcasing how that thing works and how the cycle works. And we just initialize the whole array. Okay, when that thing happens, I want to showcase something else. And that is how to write the actual memory. Because this, we just instantiate the array, we feed it with data, and that's about it. But now I want to write this array, overwrite it with data, and pretty much write to the memory itself, not to the variable, but to the memory. Because here we're going to instantiate the array, we're going to print the array, we're going to fill it with data, and so on. But I want to showcase to you guys how we can actually write the memory itself. In that case, we have address allocation, and we print out, if you want to print out the address, is done with %p. So if I specify the R here and %p, then at this 27th line, I'm going to get the address which was created here inside the memory. Having this address, now I can read the memory or write to the memory. So in that case, I define a character array of data. And I intentionally specify it to be z multiple z's because it's easier to pinpoint that into the debugger as we're going to do later on. Then after that, we are using the memcopy function, which, as the name suggests, copies to the memory, memcopy. Then here we need to pass the where we want to pretty much write to the memory. We pass what data we want to write to the memory, and we pass how much of that data we want to write to the memory. Then when that thing happens, we can again input some kind of if statements to check if that was all right. And then we print out the payload was written and press any key to exit. When you press any key, the free function is going to get called, which is going to free the memory, free the variable, sorry, and then just return out. Okay, so let's just try it out. In that case, I'm going to use not the debugger, but I'm going to attach my program to a debugger. So in that case, I'm going to open a new terminal there like that. I'm going to cd to the folder, cd desktop, malware development pointers x64 release, and then execute memory allocation.exe. Now we can input some array size. In that case, it can be 50. Then as you can see, it fills out the array with data using the for cycle. But the important part is the address of the allocated memory, which is that. In that case, we are on to the press enter to write payload to memory. In that case, we are here. Now, in order to fill the memory with this, I can just click enter or any other key. And as you can see, payload is written, press any key to exit. Now, if I press any key, the array is going to disappear and then the program is going to exit. So we don't want that. That's why I defined the get ch here. Now I'm going to start x64 dbg, which is a debugger program, which we're not going to use that much, but sometimes I think it's useful to walk through to see a different prism. Then I can go to File, Attach, and then attach the program I just executed. When attached, this debugger is going to pinpoint and stop to the exact location that the program pretty much stopped executing. Then what I can do is I can click Ctrl and G, so we can go to specific location or specific instruction, and then I can copy the address of that location, which is here. We can see that the tool says correct expression. I can click OK, and it gives us to that. Sorry, I'm going to do it again, to that specific instruction. I can click right click and then follow in dump the selected address. And when I do so, if we pay attention to the bottom pane, which is the memory dump, we can see the payload we have just written. So when you create a variable, when you instantiate that variable and fill out the array with numbers, it's not the same as write into the actual memory, which can be done with pointers and functions like memcopy and so on. So when that thing happens, now we can leverage that and move into somewhere else. And this somewhere else is called malware development. Because if we know how to operate with memory, now we can try to pretty much write malicious stuff to the memory, obfuscate the memory, execute stuff from the memory. And that's something that we all need, all want, and that's why we are here. I have one more example, but the next example will be available only to my patrons into the next video of this course series. I want to say massive thanks to my Patreon sponsors, and you keep me so much motivated to build and create more and better quality content. If you have further appreciation, don't hesitate to support me on Patreon, where you're gonna get access to all the videos to this course, which is by the way currently development, and also to a lot of tools like Shadowburn, my private packer, which currently evades some of the most known PDRs. Thank you so much for watching. Thank you so much for your attention. And if you enjoyed the video and think it was useful, make sure to hit that like button, subscribe button, or even write me a comment. This helps the channel so much. Appreciate you guys, and I'm gonna see you definitely into the next one. See ya.